Welcome to all. The title of the project is Improving Service Credibility in Password Authenticated Peer Services. And the abstract says about the project is to authenticate a client in the scenario where two peer servers cooperate for the authentication, and if one server is compromised and the attacker still cannot pretend to be client with the information from the compromised server, because no password information will be stored and keeps providing services instead of any crash report. Our two-service pack protocol is symmetric and runs in parallel in authenticating a client by encrypted key exchange, providing efficient services to users. And next one is existing system. In existing system, earlier password-based authentication systems transmitted a cryptographic hash of the password over a public channel, which makes the hash value accessible to an attacker. When this is done, and it is very common, the attacker can work offline, rapidly testing possible passwords against the true password's hash value. Typical protocols for password-based authentication assume a single server stores all the passwords necessary to authenticate clients. If the server is compromised due to, for example, hacking or installing Trojan horse, or even insider attack, user passwords stored in the server are disclosed. And next one is proposed system. In this paper, we propose a new symmetric two-server pack protocol which supports two servers to compute in parallel and meanwhile keeps efficiently for practical use. And next one is modules. In module, it consists of four types of modules. First one is secret key establishment, system initialization, user registration, and last one is authentication for peer services with DDoS resistance. First module, secret key establishment. The J2EE environment is set up and two peer servers are initialized and realize the public parameters for the user by exchange the keys using different Hellman key exchange. The secret key is established between two servers for further secure communication for peer servers. Our protocol runs in three phases: initialization, registration, and authentication, of which initialization comes under secret key establishment, which uses Diffie-Hellman key exchange. Next one is system initialization. The two peer servers S1 and S2 jointly choose a cyclic group G of large prime order Q with a generator G1. Next, S1 randomly chooses an integer S1 from ZSAR. User registration and authentication. The public parameters released by peer service will be used by client registration process, while a user registering to the peer services for encryption of password shares. Next one is registration. We refer to the concept of public key crypto system. The encryption key of one server should be unknown to another server, and the client needs to remember a password only after registration. Next one is authentication and key exchange for the peer service. The two servers S1 and S2 have received the password authentication information of a client C during the registration. The following steps are involved in the process of authentication. The Diffie-Hellman key exchange occurs between the peer servers, which run in parallel, and establishes a secret session to fetch the password authentication information, and two servers mutually generate two values and send hash functions. And this is the architecture diagram for the initialization step. And this is the session failure screenshot. This screenshot explains about the redirected servers, that is peer secure services under one umbrella. Thank you.